Okay, we're looking at whether it is possible for us to have an ability to generate information about the position of the piston as it moves inside the cylinder by having a reference to the power or the perceived power values. And what we've shown is that as you look at the doorway that is transmitting power from the transceiver through the piston and out through the door, that the amount to which this doorway is open has an effect upon how much power is coming out. And as you open and close this door, you can create a graph of received power at the transceiver on the cylinder as a function of the extent to which the door is open. And you could actually create, if you wanted to, a single line that generates for you an interpolation graph, so that if you did not know the position of the piston, but you did know the value for received power, then if you had a received power value of 6, you could come to this graph and have the opinion that the piston is sitting at a 60% aperture opening. And the transceivers that are doing this transmitting and receiving have the ability to identify themselves because they are 60 gigahertz Wi-Fi transceivers. So we wouldn't have just simply a value of 6. The actual value of 6 that we would have is that transceiver, cylinder wall transceiver D has a received power value of 6 from piston transceiver 1. So that would allow us to have an opinion about where is the piston, because we know in the piston where is the location of piston transceiver 1, and we know where is the location of cylinder wall transceiver D. So if cylinder wall transceiver D is giving a received power output of 6 for piston transceiver 1, then we know that piston transceiver 1 is in a condition where this doorway is open by about 60%. And you can see here maybe it's 70%, but the principle is the same. In other words, the central processing system would use a scientific approach by not only evaluating the value for received power, but it would be evaluating the value for received power from a specific piston transceiver to a specific cylinder wall transceiver. And if you had this graph, we can see that we've simply taken a copy of this graph and moved it over to here. And now we're only going to be looking at the lines that show the standard deviation. And when we look at the lines that show the standard deviation, we have the ability to basically create the line that constitutes the actual value plus or minus the standard deviation for this curve. And we can then remove those standard deviation values and we get a curve that has a single line, and this line could be, if we wanted it to, this line could be our line for stating if we have this received power level. We go across here, a received power level of 6 will allow us to say that we have a aperture opening of 60%.